So here's another word problem from Unit 1, Section 4. This is from the practice section of the word problems. So the question is, how many gallons of pure water should be evaporated from 160 gallons of a solution containing 12% salt so that the remaining solution contains 20% salt? So we are wanting to calculate how many gallons of pure water should be evaporated. So we want to know how much water to take out. Although it's not us physically taking out the water, at a certain point, we are subtracting the amount of water that's leaving. So here, you'll notice that a lot of these word problems do rely on a table. You don't have to use a table, but I will use a table so you have a visual. So let's see, let's make a nice table. So first, I'm noticing that our problem here calculates the amount of salt we have. Amount of salt. You'll notice that it's used as a percentage, which might feel a little bit intimidating. But to calculate a percentage, we're basically counting the amount of salt all over the amount of solution we have in total. So let's calculate amount of salt and then total solution. So if you're wondering, what's solution? Solution is basically everything combined. The salt, sorry, my line's a bit crooked. The salt and the pure water. So together, we're going to call that. I think all of my lines are a little bit tilted. I hope that's okay. Alrighty. So these are the two things we're counting. So we're going to first calculate how much did we have originally. So let's write that as the original amount. So the original amount. And then remember I told you we're going to subtract because we're going to take out. So removed. Or we can say evaporated because that's the scenario here. But I do want to let you know, depending on the word problem, the word that's being used will change. But the fact that it's being evaporated, we are losing the pure water. We're removing. Any of those words work. And then this is the new, most recent amount. New amount. New, recent, after evaporation, post evaporation amount. So let's fill in what we can. So they say that we have 160 gallons of solution. So that's what we have in total. So let's write 160 for total solution. And it says the solution contains 12% salt. So we don't want to put 12% like this because we want to know the exact amount. So we're going to calculate what is 12% of 160. So 12% of 160. So we're going to calculate that. So I'm going to calculate, I'll put a little star here so you know where to reference to this star. We're going to get 12% of 160. 12% you can represent as a fraction, 12 over 100. Of, for an operation, is multiplication, 160. You can actually also, instead of this way, change instead of a fraction to a decimal, 0.12 times 160. And you can use your calculator. So I don't think I have a calculator here. Yeah, I don't have a calculator here. But if I were to calculate a separate calculator, it's 19.2. If you had done it with a fraction, you would eventually get 19.2. But just for the sake of time, you may either use a calculator or you may solve it out on your own using fraction. So I'm going to put 19.2 up here. So I'm going to highlight this. 19.2. That's the amount of salt we have in the original solution. Now moving on to the next column, evaporated. So first, it says how many gallons of pure water should be evaporated. That's what we're looking for. So in terms of figuring out how much like water or pure water was evaporated, we don't know. So we're going to just put X. We just don't know how much evaporated. In terms of salt, amount of salt, only water is being evaporated and not the salt. So for salt, it's 0. Salt is not evaporating here. We're not removing any salt. So boom. So to get this new amount, we're going to get the original amount subtracted by the evaporated amount to get the new amount. So you'll see 19.2 minus 0 is just 19.2. 160 minus x, we're going to just represent it as 160 minus x. So now we have my most recent amount of salt, which hasn't changed, and then the amount of solution, 160 minus x. So they want, after the pure water's evaporated, we want to know how much water has to be evaporated in order for our salt to be exactly 20%. So we want this to be 20%. So if we had, I'm just going to draw a line here so we don't confuse it with our previous calculations. If we get 19.2 amount of salt over our total amount, 160 minus x, it should equal to 20% salt, because that's what we're looking for. So the salt with the total should give us the percentage of 20%. But if you represent a percent with a percentage sign, we can't calculate it, so we're going to represent as a fraction, 20 over 100. Then the left side, 19.2 all over 160 minus x. And then we're going to solve for x. For me, I'm noticing that I can divide this fraction by 20 and simplify. So I have 19.2 all over 160 minus x is equal to 1 over 5. Then from here, my x is in the denominator, which I don't want that, because in order to solve for x, it has to be in the numerator. I am going to cross multiply. I'm going to multiply these two terms together and then these two together. So we have 19.2 times 5 is equal to 1 times 160 minus x. So that doesn't change. So let me just grab my calculator here and do 19.2 times 5. Then I get 96 is equal to 160 minus x. I want to isolate x, so let's remove the 160. It's a positive 160, so I'm going to subtract 160 to both sides. Then I have negative 64 is equal to negative x. Going to divide by negative 1 both sides. 64 is equal to x. So I know sometimes when we get caught up in solving for x, we need to go back to see if we answered the question. So if we go back, they want us to know how many gallons of pure water should be evaporated. We made x the amount of solution that's being evaporated. So now my answer is going to be, since I have so much space here, 64 gallons evaporated. There you go. Once again, this is from Unit 1, Section 4.